Hello everyone. In this video we will learn to find out the integrals of the rational functions by using their partial fractions. What are rational functions? Actually, if fx and gx are two functions of x, then fx upon gx is known as a rational function. If gx is not equal to 0, there are two types of rational functions. What are those? Number one is proper rational function and another is improper rational function. What is a proper rational function? If the degree of fx we find is less than the degree of gx, then we say it is a proper rational function. For example, we have x plus 2 upon x square minus 3x plus 5. This is a proper rational function because degree of fx is 1 and degree of gx is 2. And what is an improper function? It is improper rational function if we find the degree of fx is greater than or equal to the degree of gx, then we say it is an improper rational function. For example, we have here x square plus 2 upon 3x square minus 5x plus 4. This is an improper rational function. What are partial fractions now? Let's learn partial fractions. I will explain it with the help of a rational number. Suppose we have a rational number 1 upon 6. We know the factors of 6 are 2 and 3. So, can we write this as 1 upon 2 minus 1 upon 3? One more example. Suppose we have 5 upon 6. The factors of 6 are 2 and 3, we can write this as 1 upon 2 plus 1 upon 3. So these are only known as the partial fractions of these numbers. It means if we can represent any of the rational function fx upon gx as the sum or difference of two or more rational functions, that is, we can write this as lx upon px plus mx upon qx, where we find px into qx is equal to gx. It means px and qx are the factors of gx. Then we say these are the partial fractions of the given rational function. To find the integrals of such type of functions which can be resolved into the partial fractions, we will have three types of problems. What are those? The first type we will have when the factors of gx are all linear functions and they are non-repeating. Second type we will have when the factors of gx are linear functions but they are repeating one. When the factors of gx are linear functions and at least one of them is repeating. Third type we have when at least one of the factor of gx is non-linear. When at least one factor of gx is non-linear. It means it may be quadratic or it may be cubic. We discuss a problem on the first type when the factors of gx are non-repeating linear functions of x. The question is given to us to find out the integral of x plus 1 upon x plus 2 into x plus 4. We find here these two are linear functions. We represent this as I. And we take only the integrand part, that is x plus 1 upon x plus 2 into x plus 4, and suppose its partial fractions are a upon x plus 2 and b upon x plus 4, and this is the sum of these two. Because when the factors are linear, then we will have only the constant in the numerator of each fraction. Taking the LCM, we get here x plus 2 into x plus 4, and it will be a into x plus 4 plus b into x plus 2. Now we know these two fractions are equal, their denominators are equal, it means their numerators should also be equal. So we find here a into x plus 4 plus b into x plus 2 is equal to x plus 1. From this, we have to find out the values of a and b, and that can be done by two different methods. One is by comparing the coefficients of x and the constant term on both the sides, and second is by making one of the part as 0. We will learn now making one of the part as 0. If we want to make this part as 0, we will put here x is equal to minus 4. So we get this part as 0, and this will be b into minus 4 plus 2 equal to minus 4 plus 1. Simplifying this, we get b is equal to 3 by 2. Now we'll make this part as 0, for which we will put x is equal to minus 2. We get a into minus 2 plus 4 plus 0 equal to minus 2 plus 1. When we simplify, we are getting a is equal to minus 1 by 2. After finding the values of a and b, we can substitute that values here, and then we can find out the integral of the given function, and we will write therefore I is equal to minus 1 by 2 1 upon x plus 2 dx plus b, that is 3 by 2 into 1 upon x plus 4 dx. We know the integral of 1 upon x is log x. Applying that here, we get minus 1 by 2 log of x plus 2 plus 3 by 2 log of x plus 4 plus c, base of log is e. Taking 1 by 2 common, we get here minus log of x plus 2 plus 3 log of x plus 4 plus c. Applying the law of log, we will get here 1 by 2 log of x plus 4 whole cube upon x plus 2 plus c, which is the answer to this problem. If we like to find the solution of the same problem by another method, that is by comparison of the coefficient of x and the constant terms, then what we will do? The first step will be same, second step will be same, and the same equation we will get by comparing the numerator of both the sides. After this, instead of putting the values of x as minus 4 or minus 2 or something, what we will do, we will compare the coefficients of x. Comparing the coefficients of x, we will write comparing the coefficients of x. We get a plus b equal to 1. This becomes our first equation. And comparing the constants, we will get here 4a plus 2b equal to 1. This is our second equation. This is a pair of linear equations in two variables, and we know how to find the solution of them. If we solve these equations, we will have solving equation number 1 and 2, we will get a equal to minus 1 by 2 and b equal to 3 by 2. The same values of a and b we are getting, and then we can substitute them here and then find out the integral. In the same way, we will get the same answer. It means by applying any of the two methods, we can find out the values of a and b either by comparing the coefficients and the constants or by substituting some values of x in this particular equation. In the second type, when we have the factors of gx as linear functions, but at least one of them is repeating, it means the power is more than 1. For this also, we take some example. Suppose we have been given a problem, find the integral of x upon x plus 1 square into x plus 2 dx. We find here both are linear functions of x, but x plus 1 is square, means this is repeating. Then representing this as I and taking the integrand, we can consider let x upon x plus 1 square into x plus 2 is a upon x plus 1 plus b upon square of x plus 1 plus c upon x plus 2. Since all are linear functions, we will have only the constant terms in the numerator of each. Taking the LCM, we get here x plus 1 square into x plus 2 is the LCM, and the numerator will be a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 square. Now these two are equal. It means their numerators also have to be equal. So we can write here a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 square is equal to x. And now from this equation we have to find out the values of a, b and c. That we can do by substituting some values to make one of the part as 0. For that we will put x is equal to minus 1 first. So we write here put x is equal to minus 1. We get this part as 0. This part is b into minus 1 plus 2, c into 0 and equal to minus 1. From this we get the value of b as minus 1. Now we will put x is equal to minus 2. And we get here this part is 0, this part also becomes 0, and this will be c into minus 2 plus 1 square is equal to minus 2. 1 minus 2 is minus 1 and square of minus 1 is c, so we get the value of c as minus 2 here. To find the value of a, we can substitute any value for x other than these two. So suppose we are putting x is equal to 0. We get here this is a into 0 plus 1 is 1, 0 plus 2 is 2, plus b into 0 plus 2 is 2, plus c into 0 plus 1 is 1, square of 1, and on that side it will be 0. When we simplify, we are getting 2a plus 2b plus c equal to 0. We have already obtained the values of b and c. We can substitute it here. So we are getting 2a, b is minus 1, it will be minus 2, c is minus 2 equal to 0. It means we are getting 2a equal to 4 or a equal to 2. After getting the values of a, b and c, we can substitute these values here and we can find out the integral of this. Substituting the values of a, b and c, we can write therefore I is equal to a upon x plus 1 means 2 upon x plus 1 plus b upon x plus 1 square means minus 1 upon x plus 1 square plus c upon x plus 2 means minus 2 upon x plus 2 dx. And now we know the integral of each part of it. Using the standard integrals, we will get now it is 2 into log of x plus 1 minus 1 upon x plus 1, and this is minus 2 log of x plus 2 plus c. Taking 2 common from these two terms and applying the law of log, we will have here 2 log of x plus 1 upon x plus 2. This will be plus 1 upon x plus 1 plus c, which is the answer to the problem. The third type of problem is when at least one factor of gx is non-linear. Let's take one example for this also. Suppose we have been given a problem, find the integral of 2 upon x plus 1 into x square plus 4. We find here this factor is a quadratic function and we can't further factorize it. So what we do in such problem? Representing this as I, we take the integrand part and we write let 2 upon x plus 1 into x square plus 4 equal to a upon x plus 1. This is a linear factor or constant as the numerator, plus bx plus c upon x square plus 4. The only thing is we have to mind that this is a quadratic factor, so here it will be a linear function. If it is cubic, here we will have the quadratic function. So that is the thing we have to remember, that the numerator will be having the degree 1 less than the degree of the denominator. Taking the LCM, we get here x plus 1 into x square plus 4. It is a into x square plus 4 plus bx plus c into x plus 1. From this, by comparing the numerators, we get a into x square plus 4 plus bx plus c into x plus 1 equal to 2. To find the values of a, b, c from this equation, we put x is equal to minus 1 first to make this as 0. And then we get this will be 1 plus 4. This will be 0 equal to 2. It means 5a equal to 2, or we can say a equal to 2 upon 5. Now substitute any value of x here. Suppose we are putting x is equal to 0. So we will get a into 4 plus c into 1 equal to 2. Simplifying, we are getting 4a plus c equal to 2. We know the value of a here, so we will substitute the value of a, that is 4 into 2 upon 5 plus c equal to 2. Simplifying this, we are getting c is equal to 2 minus 8 upon 5. This is equal to 2 upon 5. Now we can put x as 1. If we put the value of x as 1, this will be a into 1 plus 4 plus b plus c into 1 plus 1 equal to 2, which gives us 5a plus 2b plus 2c equal to 2. Substituting the values of a and c here, we will get 5a is equal to 2, so this is 2, plus 2b plus 2c will be 4 by 5 is equal to 2. This 2 and 2 cancel and we are getting 2b equal to minus 4 upon 5, or b is minus 2 upon 5. After finding the values of a, b and c, we can write therefore I is equal to a upon x plus 1, that is 2 upon 5 into x plus 1, plus bx plus c. b is minus 2 upon 5x plus c is 2 upon 5 upon x square plus 4, integral of this. We can separately find out the integrals of each. We can write this as 2 upon 5 integral of 1 upon x plus 1 minus 1 upon 5 into 2x upon x square plus 4 and plus 2 upon 5 into 1 upon x square plus 2 square. Now, if we consider fx as x square plus 4, it means f dash x will be equal to 2x. And we know the integral of f dash x upon fx dx is equal to log of fx. We also know integral of 1 upon x square plus a square is 1 upon a tan inverse x upon a. If we apply these two here, we get 2 upon 5 log of x plus 1 minus 1 upon 5 log of x square plus 4 plus 2 upon 5 into 1 upon 2 tan inverse x upon 2 plus c. This 2 and 2 cancel. Taking 1 upon 5 common, we get here 2 log of x plus 1 minus log of x square plus 4 plus 1 upon 5 tan inverse x upon 2 plus c, which is the answer to the problem. For the application of partial fractions in case of integrals of improper rational functions, what we do, let's learn now. If fx upon gx is an improper rational function, we know that degree of fx is greater than or equal to degree of gx. Then divide fx by gx and reduce as fx upon gx equal to px plus qx upon gx. Then we can find out the factors of gx and find the partial fractions of it, or we can say we can reduce it to the partial fractions. This is px plus, suppose it is lx upon mx plus rx upon tx, where mx and tx are the factors of gx. We can write where tx into mx is equal to gx, and then we can make use of partial fractions and find the integrals of such type of functions. To understand this, we take an example. Here we find that the degree of numerator is 3 and that of the denominator is 2. It means the degree of numerator is greater than the degree of the denominator. Degree of fx is greater than the degree of gx. So we divide it. X cube plus 3x plus 5, when we divide by x square plus 5x plus 4, it goes x times. This is x cube plus 5x square plus 4x. Subtract, cancels, minus minus. This comes as minus 5x square minus x plus 5. Minus 5, it is minus 5x square minus 25x minus 20 plus plus plus. This cancels. This is 24x plus 25. So we write this as integral of x minus 5 plus 24x plus 25 divided by x square plus 5x plus 4 dx. We can also write this as integral of x minus 5 dx plus integral of 24x plus 25 upon x plus 1 into x plus 4 dx. These are the factors of this. We represent this by I, and suppose this we take as I1. Then we write I1 is equal to integral of 24x plus 25 upon x plus 1 into x plus 4. And we consider let 24x plus 25 upon x plus 1 into x plus 4b a upon x plus 1 plus b upon x plus 4. Taking the LCM and comparing the numerators, we will get a into x plus 4 plus b into x plus 1 equal to 24x plus 25. To find the values of a and b, we substitute here, put x is equal to minus 4, which will imply this is 0, b into minus 4 plus 1 equal to minus 96 plus 25. It means we are getting here minus 3b is equal to minus 71. This gives us b is equal to 71 upon 3. After finding the value of b, we put x is equal to minus 1. Then we get here a into minus 1 plus 4 plus 0 equal to minus 24 plus 25, or we can say 3a is equal to 1, or a is equal to 1 upon 3. So we have got the values of a and b both, and next we will integrate this. After finding the values of a and b, we can write here I is equal to integral of x minus 5 plus integral of a means 1 upon 3 into 1 upon x plus 1. B means 71 upon 3 into 1 upon x plus 4, which is integral of x minus 5 plus 1 upon 3 integral of 1 upon x plus 1 plus 71 upon 3 integral of 1 upon x plus 4. Now we can write the integrals of each part. X square by 2 minus 5x plus 1 upon 3 log of x plus 1 plus 71 upon 3 log of x plus 4 plus c. And this is the answer to the problem. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.